Zeal Education Society, redefining excellence.
Hello student, I am Dr. Mahadev Unde, Professor, Zeal College of Engineering and Research, Pune. In the last video lecture, we have learned how the armature windings are connected in star or delta, and what are the line voltages, line currents, phase voltages and phase currents, etc. In this video lecture, we are going to find out the relationship between line values and phase values of voltage and current in case of balanced star connected inductive load. So let us start. Let us draw the diagram for the star connected balanced load. So here this is the supply system RYB, three-phase supply. And this R to R dash, this is the line, Y to Y dash, this is the line, and B to B dash, these are the three lines. And here it is, the loads are connected in the star fashion. So it is a three-phase star connected inductive load. Inductive load. And therefore, and this is the neutral. The current flowing through the lines is known as line current, and voltage between two lines is known as line voltage. And current flowing through the respective phase of a load is known as phase current. Also, in case of star connection, the voltage between any line and neutral is also known as phase voltage. So, for the balance supply system, okay, we will show the various line currents and the line voltages as well the phase currents and the phase voltages. So here it is I capital R, current flowing through the Y line is IY, and current flowing through the B line is capital IB. Now here the current flowing through the phase of a load is nothing but capital R small r. IY and this is IB. So these are the phase currents. Then the voltage between any two lines is known as the line voltage. So this is between R and Y. This is phi RY. Then between Y and B, phi YB. And between B and R, it is phi BR. This is as per the phase sequence RYB. Phase sequence RYB means you have to find out the voltage between R and Y and B, and then B and R. So these are the line voltages, and see the phase voltages, the voltage between any line and neutral. So for the balance supply system, for system, let phi RY equal to phi YB equal to phi BR equal to phi L dash line voltage. Also, phi Rn equal to phi Yn equal to phi Bn equal to phi pH phase voltage. Then for the balance load, let capital IR equal to capital IY equal to capital IB equal to IL, that is line current. Also, capital I small r equal to capital I small y equal to capital I small b equal to IPH phase current. So this is equation 2, this is equation 1. Then the current relation. Current relation. Now if you observe the diagram carefully, observe the line current and the phase current. It is observed that same line current enters into the respective phase of a load, and therefore we can make the conclusion line current equal to phase current. So it is observed that same line current enter into respective phase of a load, and therefore I capital R equal to I small r, I capital Y equal to I small y, I capital B equal to I small b. Therefore, I line equal to I phase. Thus, we can write IPH equal to IL. So here, we can make the statement, in case of star connected load, the phase current equal to line current, or we can say line current equal to phase current. Now see the voltage relation. Voltage relation. Now here the voltage relations phi Ry is nothing but phi Rn minus phi Yn. Similarly, phi Yb equal to phi Yn minus phi Bn, and phi Br equal to phi Bn minus phi Rn. Now from these relations, so it indicates that if you apply the Kirchhoff's voltage law, between say R and Y, so phi Ry is nothing but phi Rn plus phi Rn minus phi Yn. Phi Rn minus phi Yn, and similarly we can write like this, and therefore we'll draw the phasor diagram from this. Say, assuming that the load is inductive, already we have mentioned. Here it is we have to draw the phasor diagram on 4-phase basis. So first of all, draw the phi Rn equal to phi pH. Phi Rn, then equal magnitude. Consider the equal magnitude. Say this is phi Yn. This is nothing but phi pH, and this is phi B, phi Bn. This is also phi pH. So we have drawn all the phase voltages equal in magnitude and displaced from each other by 120 degree electrically apart. For simplicity, to avoid the complications, I am not showing here the 120 degree electrical, but it is drawn at a 120 degree electrically. Now, as the load is inductive, the respective currents are lagging the voltage by an angle phi. Say, and we have to draw the currents in equal magnitude and distance from each other by equal angle, that is 120 degree. Say this is I small r is nothing but IPH, and this angle is phi. So equal magnitude. See, this is lagging. So here it is IY, and this is IB. This angle is phi. This angle is phi. So if we observe carefully, see the counterclockwise rotation. IR is lagged by IRN, VPH by angle phi. This is IY lags the PN by Phy by angle phi, etc. Now what to do? Now here, as per the equation number 4, the line voltage Phy Ry equal to Phy Rn minus Phy Yn. Phy Rn is here, minus Vn, Phy Yn, we have to draw in opposite direction of equal magnitude. So this is minus Phy Yn. And now add these two vectors or two phasors. And find the resultant. So this is O. So this is V, and this is nothing but Pry equal to Phi L. Pry equal to Phi L. So in this way we have obtained the Phi L. Similarly, we can obtain Phi YB. Phi YB is nothing but Phy Y minus Pb. Means in this direction we can add this together. Similarly, Phi BR. So Phi B is here minus Phi R. Minus Phi R you have to draw here and you have to add this. But for obtaining the relation, one is sufficient. And now let us find out the angle between the line voltage and the phase voltage. Now if you observe carefully, the angle between Phy Yn and minus Phy Yn is 180 degree. Out of that, the angle between Phy Yn and Phy Rn is 120. So this is 60 degree. This is 60 degree, and therefore this is 30 degree. This is 30 degree. And let us draw the perpendicular bisector on the OB line. So this is A. This is 90 degree. This is 90 degree. Now for the triangle OAC, say this is C. OAC. From the triangle OAC, from triangle OAC. Now see, OA is base, AC is height, and OC is the hypotenuse. So cos 30 degree equal to OA divided by OC. OA divided by OC, and therefore OA equal to OC into cos 30 degree. But what is Phi RL? But Phi Ry equal to Phi L equal to 2 times OA, because this is the perpendicular bisector. 2 times OA, and this is nothing but OB. So this is equal to 2 times OC into cos 30. But what is OC? OC is Phi Rn. So Phi Ry equal to 2 times Phi Rn into cos 30 is root 3 by 2. So this 2 will cancel, and therefore Phi Ry equal to root 3 into phi Rn. So phi line, phi Ry is nothing but phi line, phi L equal to root 3, and phi Rn is nothing but phi pH. So phi pH, and therefore phi pH equal to pL divided by root 3. So in this way, we have obtained both the relations, that is, this is equation number 5. So in case of star connection, the per phase voltage equal to line voltage divided by root 3. So in this way, we have obtained the current relation and voltage relation. Now let us obtain the power relation. Phasor diagram, phase sequence, RYB and inductive load. And inductive load. Now here power relations. Now power per phase PPH equal to phi pH IPH into cosine of angle between them, cos. So PPH equal to, what is phi pH? Phi pH is phi L upon root 3. Or therefore 3-phase power directly we can consider. 3-phase power, say denoted by capital P. Capital P equal to 3 times PPH IPH into cos. So this is 3 multiplied by, what is PPH? PL upon root 3. What is IL? IPH? IPH is nothing but IL into cos. Therefore P equal to, this is root 3 PL IL into cos. This unit is watt, bigger unit is kilowatt or megawatt. Now in this way we have obtained the active power relations. Power relation, once we use the word power, means it is always active. And this is a root 3 into VL, line voltage into line current into cosine of angle between phi pH and IPH. Phi pH and IPH. This is phi pH, this is IPH. Angle is phi. Similarly, the reactive power, Q. Q equal to root 3 PL IL sin phi. Unit is VAR or kVAR or MVAR. Then the apparent power, S. So S equal to root 3 PL IL. Unit is VA or kVA or MVA. Thus, S equal to square root of P square plus Q square, and power factor equal to cos phi. Cos phi equal to, see here from this relation, cos phi equal to P upon root 3 VL, root 3 VL or it is a P upon S, P upon S. See, this root 3 VL is nothing but S. So P S into cos phi. So therefore cos phi is P upon S. So in this way we have obtained these relations. So in this way we have obtained the current relation, voltage relation and power relations. So in case of star connected load, 3-phase balance star connected inductive load or lead capacity load. Here we have considered the inductive load. The current relation is IPH equal to IL as it is, and it is very easy to observe. Then phi pH equal to PL upon root 3 and the active power P equal to root 3 VLIL cos phi. Similarly, the reactive power root 3 VLIL sin phi, and the apparent power is root 3 into P into I. In this way, we will finish here. We stop.